Hello everyone, in this video let's discuss about RC phase shift oscillator. If you are new to our channel, please subscribe for more engineering related topics. In RC phase shift oscillator, let's discuss about the oscillator first. So if we consider the oscillator, any oscillator will be having two stages. Any oscillator will be having two stages. First one is amplifier stage. First one is amplifier stage and second one will be feedback stage. Amplifier stage and feedback stage. So these both amplifier and feedback must satisfy the Barkhausen criteria. So this will be the amplifier and this will be the feedback. Feedback will be represented using beta and amplifier using A, which produces the output voltage if you give the input as a voltage waveform. So amplifier and feedback must satisfy the Barkhausen criteria. So what is Barkhausen criteria? A into beta must be equal to 1. That is, amplifier and feedback must be equal to 1. And angle between the amplifier and the feedback must be equal to 0 degree or 360 degree. If you start a cycle right here, it will be 0 degree. If you come again to this point, it will be 360 degree. Therefore, 360 degree and 0 degree will be same itself. Angle. This angle A beta is equal to 0 or 360 degree. We can call it as the phase angle between input and output. Phase angle between input and output. Phase angle between input and output. In the feedback, that is in between amplifier and feedback, in feedback we will use RC networks. We will use RC network. What is RC network? RC network is the combination of resistors and capacitor network. So this oscillator is called as RC phase shift oscillator. Since we are using RC network in the feedback, it will be called as the RC phase shift oscillator. As we know, 0 degree is equal to 360 degree. Now, to get 360 degree phase shift, amplifier and feedback must produce 180 degree phase shift. So, amplifier and feedback. If both of them will produce 180 degree phase shift, that is amplifier with 180 degree phase shift and feedback with 180 degree phase shift, then with combination of them 360 degree phase shift will happen. Therefore, we can satisfy the Barkhausen criteria, that is the phase angle between input and output will be equal to 360 degree or 0 degree. Now, I already said that RC network will be used in the feedback. So if I consider one capacitor and resistor in series, this one CR network or CR circuit with one capacitor and one resistor, it can produce between 0 degree to 90 degree of phase shift. So 0 to 90 degree of phase shift. So to get the maximum phase shift, that is 90 degree, R value must be equal to 0. If R value is equal to 0, we will get the maximum phase shift, that is 90 degree from one circuit. Now, I said that in feedback, it must provide 180 degree phase shift. So, if we put 2 capacitor and 2 resistor, RRCC. So capacitor and resistor in series, capacitor and resistor in series. Now we use 2 capacitors and 2 resistors. Now the capacitor and the resistor network can produce the phase shift up to 180 degree. To get 180 degree, this R value must be equal to 0, this R value must be equal to 0. Therefore 90 degree phase shift, 90 degree phase shift. What it will be? 180 degree phase shift we can satisfy. But when R value will be equal to 0, when R value will be equal to 0, gain will become 0. So the gain will become 0. So we should not get the gain as 0. So we will use another technique, that is we will be using 3 RC network, that is 3 RC network, 3C, 3R. So if you divide 180 degree by 3, what will it be? 60 degree. So I said 1 C and R combination will produce up to 0 to 90 degree. So 60 degree is in between 0 to 90 degree. They can easily provide 60 degree of the phase shift. Each CR network can give up to 60 degree phase shift. Therefore we can satisfy 180 degree feedback phase shift. So when providing the 60 degree phase shift, the R value will not be equal to 0. Therefore we will get the gain and the conditions will be satisfied. Now let's draw the circuit. To draw the circuit, I said 180 degree phase shift from amplifier and 180 degree phase shift from feedback. To get feedback phase shift, we already used 3 RC network. To get the amplifier 180 degree phase shift, we will use the inverting amplifier. So and in feedback we will be using RC network. Using these two, inverting amplifier with RC network, we will construct the RC phase shift oscillator. So while constructing the inverting amplifier, this is called as the operational amplifier. We will use the operational amplifier to convert inverting amplifier. This operational amplifier op-amp will be having two terminals, negative terminal and positive terminal. If you give the input to the negative terminal, the output will be of the inverted amplified. The output will be of inverting and the output will be amplified. Therefore it will be called as inverting amplifier. So I will give the input to the negative. So I said 3 CR network, C, R. So this will be grounded. R. This is output voltage. Now seeing this circuit, we can say that the output of the operational amplifier is input to the CR network or RC network. The output of the RC network is input to the op-amp or the operational amplifier. So output of RC network is input to amplifier. Next output of the RC network, output of amplifier. Output of the amplifier will be input to the RC network. Input to RC network. So in this RC network where resistor and capacitors are there, in this RC network there will be the production of the oscillation. So for production of oscillation, there need not, for the production of oscillation we don't need any output signal. So for the production of the oscillation we do not need any input signal. This oscillation will be because of the thermal noise outside. So the thermal noise outside will act as an input for the production of the oscillation in the CR network. So this thermal noise will create the oscillation. Because of this oscillation, multiple frequency ranges are formed. Multiple frequency ranges or components will be formed. So in this multiple frequency component, one intermediate frequency component will be selected. One intermediate frequency component. not high, not low. Intermediate frequency component will be selected. So this intermediate frequency component which is selected in the CR network or RC network will act as an input to the amplifier. Now let us discuss about the beta value, that is feedback. So in the RC phase shift oscillator, the beta value will be constant, that is 1 by 29. So we already know A beta is equal to 1. So from this, beta value is equal to 1 by 29 means what will be the A value? 1 by A, that is A value will be equal to 29. We got the amplifier value, that is 29, and beta, that is feedback value, that is 1 by 29. Therefore 1 by 29 into 29 will be 29 will get cancelled, and A beta value will be equal to 1. Now I earlier said that one frequency component will be selected among the multiple frequency component which are produced due to the oscillation. So what will be its formula? Frequency F is equal to 1 by 2 pi RC root 2n for the n number of RC network. What will it be? For n number of RC network, 1 by 2 pi, R means resistor, C means capacitor, root 2n, because this capacitor and resistor value will be same. If they are not same, we cannot get the constant 60 degree of the phase shift. So R and C value will be same into root of 2n. 2n means number of CR combination. Here how many combinations we have used? 1, 2, 3. 3 combination of CR networks we have used. So what it will be in this RC phase shift oscillator condition? 1 by 2 pi RC into root of 2n. n is 3. So 3 2s are 6. 1 by 2 pi RC root of 6 will be the intermediate frequency component value which has been selected and which will act as an input to the operational amplifiers. Hope you understood the video. If you like the video, please subscribe for more engineering related topics. Thank you.